x1, xn from any distribution with mean mu and variance sigma squared. I wanted to show that the sample mean sample variance, sorry. Unbiased for population variance. So I've done this in a previous lecture. So to show that it is unbiased, you just show that the expectation on this is sigma squared. Okay. And one way to show this is you expand this thing. So E s squared, this is a constant. 1 minus m minus 1 is a constant, so I can take it out. And you should know that if you expand this, do you know how to go from here to here? No? So, summation, okay, I do not write I from 1 to n for simplicity. Xi minus x bar squared is what? The summation xi squared minus 2 x bar times xi plus xi squared. And x bar squared. Okay. Just expand it squared. And then I do the summation separately. This is summation of xi squared minus 2 times the summation x bar times xi plus summation of x bar squared. Okay. x bar does not go from 1 to n, so I can take this x bar out of this summation. This is just sum of xi squared minus 2x bar sum n xi plus sum I from 1 to n x bar squared, which is just n times x bar squared. Okay. And what is summation of I from 1 to n xi? Is n times x bar. Okay. So I have summation of xi squared times 2n x bar times x bar, so it is x bar squared plus n times x bar squared. Okay. So this gives you I mean, as long as you do this once, whenever you bump up into this term, you should immediately know that it can be right there. See this thing? Okay. So, because expectation is linear, this is 1 n minus 1. Simplify from 1 to n dxi squared. Minus n times the expectation of x bar squared. Okay. And let me write it down here. So what is exi squared? It is the variance of xi plus the expectation of xi squared. Okay. We use this formula again. This is used a lot. Okay. And this is just comes from the formula for variance. Okay. Because variance is ex squared minus mean squared. So you move term to the right hand side. Okay. And this is sigma squared plus exi is mu, so it's plus mu squared. And by the same token, x bar squared is variance of x bar, which is sigma squared over n. And the expectation of x bar is mu. Okay. And then you plug these two things to this term. So you have 1 and minus 1. Those exi squared are all equal to this thing. So it is n sigma squared minus n times this. N sigma squared minus sigma squared minus n times mu squared. Okay. And these two terms cancel. So I have m minus 1 times sigma squared. So this is just sigma squared. So it is indeed unbiased. Okay? And there are another way to show this. Okay. Do you want me to talk about another way, or?
Is it simpler? Is it easier, or no?
I'm not sure if it is easier.
And there's no point.
Okay, let me briefly talk about the other way to do it.
Sure. Stop it.